Hello everyone, my student number is 10454-163. Today I will introduce about IP, the Internet Protocol. It is a principal communication protocol in the Internet Protocol suite for relaying datagrams across network boundaries. Its routing function enables Internet working and accidental established Internet. IP has a task of delivering packets from the sources host to the destination host solely based on the IP address in the packet headers. For this purpose, IP defines a package structure that encapsulated the data to be delivered. It also defines the driving methods that are used to label the datagram with the source and destination information. IPv4 is the fourth version of the Internet Protocol. It is one of the core protocol of the standard basis Internet working method in the Internet and other packet switches the networks. IPv4 is a connectionless protocol and operates on the best effect delivery model, in that it does not graduate delivery, nor does it assure a proper screens or avoidance of public delivery. This accepts, including data integrity, and are addressed by a upper layer transport protocol, such as a transmission control protocol. In this upper layer protocol is a UDP. The Internet header length (IHL) field has 4 bits, which is the number of 32 bits worth. Identification. This field is an authentication field, and it is primarily used for unclearly evidently the group of the fragments of a single IP datagram. Some experimental works has just using the ID field for other purposes, such as for adding packet trace information to help trace datagram with the support sources address. But RFC 6864 now prohibits any such use. And time to live. 8 bits time to live field helps prevent datagram from persisting on the Internet. This field limited datagram's lifetime. It is specific in the seconds, but time intervals less than 1 second are rounded to up to 1. In practice, the field has become a hop count. When the datagram arrived at the router decrements the TTL field by 1. When the TTL field hits 0, the router discards the packet and typically sends an ICMP time extending message to sender. The program tracing router uses this ICMP time exceed the message to point the router used by the package to go from the sources to the destination. And then I will introduce about the IP in the Wireshark. What I've done is in the browser I have opened up a connection to MIT.edu, and what I'm going to do is following through that connection and show how it found the resources, and then send it first a data packet to it. So the first thing that the system does it is need to figure out what port number to use. So when I open up to the web browser and go to the MIT.edu, depending on how I enter the address into the address bar of the browser, then the next thing it has to do is figure out where the service is. So I went to the MIT.edu, but my system didn't know where MIT.edu resides. DNS deal with the resolution of a name to the address, and so my system took a look at the DNS cache on my local system, which is a rolling cache of the addresses that it has already resolved, and it looked for the MIT.edu, and it should solve that MIT.edu didn't exist in the cache. So it said, okay, I need to go to send that out to my DNS service to get a hopeful response. Where is the resources? Is located my DNS service happen to be on my gateway, which is 71.226. This is common for standard home networks. It may not be there. It could have been a roommate resources as well, such as Google DNS service or Open DNS or some others. If this is a remote DNS service that I'm trying to connect to, then my system is going to take a look in my router table and figure out where does it need to go in order to access that DNS service. So if it's a remote outside of my network, it's going to take a look at my router table and realize that it has go out through my gateway in order to go talk to the DNS service. And when it does so, it's going to check my ERP cache to see if there are a layer to address for my gateway, so that it can be sent a frame to the gateway. If my system didn't have a ERP cache entry for my gateway, then my system would have sent a ERP packet out looking for the physical address for 68.87.71.226, and my system happened to have it in its ERP cache since I commonly access that IP address, and so we don't see an ERP package here. What we do see here is the first package is a DNS package. So my system saw that it was 71.226 was my DNS server, and it knew that it was a local resources. It checked my router table. It realized that on my physical interface, we are already connected to the 71 network. And I already had in ERP cache entry for the 71.226. So it didn't need any information, and it automatically built the DNS packet. And it built all that without having produced any other packets to find this information. So my system then sent out its DNS request asking for the MIT.edu, and if we go down and take a look at the IPv4. Look down the user datagram UDP section. Here we can see there is a using protocol 53, which is for the DNS, and is if we spend DNS, we can look at the requires and about the MIT.edu. Then we have to wait for the DNS response. Then we see the next packet. Here from DNS, we receive a standard required response from MIT.edu. And if we look at DNS in package detail, we can see the answer on the below, and there is a record entrance at this IP. The record entrance is what we care about. So now my system has an IP address here from the MIT.edu, so that I can build a TCP handshake to MIT.edu to the web server, so that it can begin following GTP date back to the source. So that's all what I want to introduce about. So thank you.